Assalamualaikum warahmatullahi wabarakatuh. My name is Adi Utarini. I'm from Department of Health Policy and Management, Faculty of Medicine, Universitas Gadjah Mada in Indonesia. My sincere apology for not being able to be physically present with all of you today. And I really would like to appreciate the organizer for still providing the opportunity for us to present this case study. I'm the principal investigator of a project called Eliminate Dengue Project Yogyakarta from 2013 up to current. And then on the second part of the presentation will be delivered by Dr. Egy Arguni, a pediatrician, PhD. She was the PI for the period of 2011 for 2013, and she is with all of you now. The project itself is about dengue. So we will start with a little bit of the burden of dengue in Indonesia, and then the innovation that we are doing in this project, which basically use what is called Wolbachia Aedes aegypti technology. The study has been started since 2011, and we went through different phases of the study up to now. So we will share that phases with you, including some of the key findings, and within that we will build the 3 case studies for the discussion more from the perspective of ethics. The first one is about community opposition. Second one is how we move from individual informed consent towards community informed consent. And then the third case study is about public open randomization, when we did it in the phase of the project where we did randomized controlled trial study. And then finally is how are we going to move forward. Speaking about dengue, we all know that dengue is still a global health problem, and the latest estimate of dengue, this is produced by Bat and colleague in 2013, showed that the actual burden is much higher than the WHO estimate, which is 390 million person infected per year. Now, according to the WHO latest report on dengue control, Indonesia was placed as the second country with the highest burden of dengue in the world. And despite all the efforts in the dengue control program that has been organized by the Ministry of Health, globally I think we saw also challenges that the current program has not been able to in an optimum way prevent dengue. And this was also recognized in the WHO latest report, that we really need a lot of innovation techniques and methods to improve dengue prevention and control. Now the project was basically used this bacteria, natural bacteria occurring in wild insects. In fact, the majority of insects, around 70%, has this Wolbachia. But the innovation is that the Wolbachia was injected through in the Aedes aegypti mosquitoes. So this project has not only been done in Indonesia, but it also now is currently ongoing in other countries, such as in Australia, where the principal investigator global sits at Monash University, and then similar study undergoing in Vietnam, in Brazil, Colombia, and some other countries are just joining this EDP program also. For example, India, Mexico, New Caledonia, and Pacific Islands. Now recently, last year, WHO has already stated, and this is stated by the Factor Control Advisory Group, that already recommends the community trial of Wolbachia Aedes aegypti with strict monitoring and also a large-scale release. Now the project itself, the one in Indonesia, is funded by Tahia Foundation, and in global and also in other countries is funded through different sources. Now we would like to show a short video describing more the technology, so you have the perspective to see what's the challenges when we deliver this project in the community.
The mosquito known as Aedes aegypti originated in Africa. Over the last 400 years, it is spread throughout all tropical regions of the world, transmitting viruses to people. We are working on a way to stop this mosquito from transmitting dengue. Our method uses naturally occurring bacteria called Wolbachia that live inside insect cells and are passed from one generation to the next through the insect's eggs. Wolbachia are found naturally in up to 60% of all the different species of insects. Insects that include fruit flies, moths, dragonflies, and butterflies. The secret to the success of Wolbachia is how it manipulates the reproduction of the insects it lives in, so to give itself an advantage. It works like this. If a male insect has Wolbachia and mates with a female that doesn't, then the eggs she lays won't hatch. If the female has Wolbachia and the male doesn't, she would lay her normal number of eggs. They would all hatch and all offspring will carry Wolbachia. When two insects that both carry Wolbachia mate, the eggs will hatch and all offspring will carry Wolbachia. Over a few generations, the number of individuals with Wolbachia increases until nearly all the insects within a population have the bacteria. We wanted to see if we could use Wolbachia as a way to stop dengue transmission. To do this, we first had to move Wolbachia into the mosquito so that it would grow and be passed between generations. Using microscopic needles, we took Wolbachia from the fruit fly and injected it directly into young Aedes aegypti eggs. It took us thousands and thousands of attempts, but finally we were successful. We then took the mosquitoes that contained Wolbachia and infected them with dengue virus, and found something really exciting. The virus didn't grow well in the mosquito, and if it can't grow, it can't be passed between people. Our next step was to build large enclosed outdoor cages in northern Australia that we filled with local mosquitoes. We then introduced mosquitoes containing Wolbachia to see if it spread into the cage population, and it did. We now wanted to test the method where dengue is found. We needed the government to examine the safety of our method and approve our trials. Then we needed to gain approval from communities to release mosquitoes containing Wolbachia. With these approvals and community support, we began our first open field trials in Australia in 2011. Wolbachia mosquitoes were released once a week for 10 weeks, and within a few months, close to 100% of the mosquitoes had Wolbachia. And years later, they still do. Ongoing trials in Australia and dengue-endemic countries are now determining the best way to deploy Wolbachia across whole cities. It is our hope that with continued success, the Wolbachia dengue control method will reduce dengue transmission and protect the health of the 2.5 billion people that live in dengue transmission areas.
Now the video shows how the innovation started, how Wolbachia was injected into the Aedes aegypti eggs in Australia in Monash laboratory, and then it also shows how Wolbachia can be spread into the general population of mosquitoes. So having understood sort of the basic mechanisms of the intervention itself, now we would like to present how we develop the study phases in EDP Jogja. Yeah, we started in 2011, and the first 2 years of the project, this was again led by Dr. Egy Arguni, a pediatrician PhD. The first 2 years we were focusing so much on the safety aspect and the feasibility of our team to be able to produce the mosquitoes and to produce also the adequate number of later eggs, mosquito eggs. So that's when we also make sure that the Wolbachia that we use, and this was taken from the Drosophila melanogaster, was really and genetically identical with Wolbachia that are circulating in the mosquitoes in Yogyakarta. So that was done through laboratory process, and also secondly that we have to be sure that the mosquito that we produce, Aedes aegypti with Wolbachia, the mosquito characteristics is also very identical with the Aedes aegypti mosquitoes in the local population. Now this is a critical point, because in order for Wolbachia to spread naturally, then what we want is really the mosquito that we release in the population can mate with the local Aedes aegypti mosquitoes in the population. So therefore, then Wolbachia can be spread naturally and can be established in the community. So that was what's happening in the first 2 years. It's the technology of the Wolbachia itself. It's about building our infrastructure in the campus. And also another important point is that certainly we need to work with the community from the beginning. And for a technology project like this, in fact, community is the critical point. It is up to them if they want to accept this project or not. So therefore, from the beginning, we need to make the journey together with the community to make them understand, okay, what is dengue, what causes dengue, and then what is the characteristics of the mosquito, which is Aedes aegypti, and then finally we try to describe what is Wolbachia and how it works that can suppress viral replication in the mosquito. So I mean, this obviously is not a short journey. This is something that we have to be working very intensive, communicate very intensively with the community. So that was phase 1. And then during phase 2 is the actual pilot release. And the pilot release is done in 4 sites, 2 sites in a district called Sleman. And then 6 months after the first pilot release, we did the second pilot release was conducted in Bantul district. Now, during this pilot release occurred between 2013 to 2015, what we hypothesized is actually whether Wolbachia can be established in the local community, local mosquito populations. So whether they can establish there, and then secondly, those Aedes aegypti who is already in the community, whether they still have the characteristics of being able to suppress virus dengue replication in the mosquito. These two needs to happen first before we expect that Wolbachia can reduce dengue in the population. So during phase 2, again, this is a pilot release, and this is done in the population of total around 10,000 people in these 4 sites. It's small sites, and this is when the case study, the community opposition, and also moving from individual to community consent will be built. Now, after we did the phase 2 pilot release, and the results was quite positive, which we will show you later, then what we did was to really look deeper into the risk assessment process. And to be fair, and also to give this as a rigorous scientific exercise, the risk assessment was not done by us, but it was done by an independent risk assessment team, and this is established by the Ministry of Research, Technology, Higher Education, and Ministry of Health. So the result from this risk assessment team was basically saying that the risk due to the release of mosquito Wolbachia with Aedes aegypti for the period of 30 years was negligible. So with that statement, we then move to the next phase, which is phase 3, and this is the large-scale release of Wolbachia deployment. And during phase 3 is when we intend to do the impact study. And we call the study the ORD study. This is applying Wolbachia to eliminate dengue project. And this is done in Yogyakarta city, Yogyakarta municipality, with a total population of 400,000 population. So during this phase is when we really want to look at, okay, once we know that Wolbachia can be established and still have the factor competence of suppressing dengue virus in the mosquito, now we want to prove, to give the evidence how much it can reduce dengue in the community. Now this study will be conducted up to 2019, and then hopefully, and so far also the evidence that we have seem to be quite positive. So the next step would then be more intensive communication and advocacy to policy level, whether it's a central level or at the regional level, with the hope that many more people, the society, can benefit from this technology. So this is the overall study phases, and again we will present the case study on community opposition and moving from individual to collective community consent during pilot release, and then the final case study on public randomization. This is built in during the phase 3, which is the current phase of the project. Now, to give you a picture of the release sites, Indonesia has many islands, and this study was done in Java Island, which is the main island, and one of the province is Yogyakarta Special Province. Now, the province consists of one city, which is Yogyakarta City, and 4 districts. 2 out of the districts, which is called Sleman and Bantul, is where we did the pilot release. In Sleman, we did the pilot release in Nokotirto and Kronggahan villages, whereas in Bantul district, we did the pilot release in Singosaren and Jomblangan. And then the area in the middle, this is where the Yogyakarta city lies. Yeah. So this is to give you also the sense of how we move the scale from pilot release to the large scale release. Now, this is a very brief introduction of the Eliminate Dengue project in Yogyakarta. And after this, I would like to hand over to Dr. Egy Arguni, pediatrician PhD, and she will take you to the some key results in the study phases as well as the case study. So thank you very much for your attention.